Last week I've been working with Shehan on his client request sequencer and rewrote it, and also we're trying to add a unit test for it. And that's me, 春梅.
I'm working on the 3D testing. So this is the testing result. And debug build works. Release build has a crash. I have told Sam. I haven't got the reason why the release build crashed. But for the real hard disk read and write, the read is about 2 milliseconds. It is too slow.
Yeah, on my implementation or in my build environment, the release build does work and it's about 10 times faster, give or take. I mean, it's still not fast, but it's faster than the debug build.
Oh, okay.
Yeah, what you're seeing is a timing-related crash or a difference in how the reactor is doing scheduling. You may be able to find it by inspection if you start reading code. If you don't, though, I'm not hyper interested in this just now because I'm still making changes to those bits of code. And I'm about to, once I get a little bit further in integrating the ONode, OMAP, and collection interfaces into CStore, I'm going to add CStore itself to that tool. At which point I'm going to have to do yet another round of debugging. So this may just be a thing to do later, basically. But if you want to debug it, you're welcome to. I just don't have enough information at this time to do so. You might be able to get there. You might be able to get there by adding more asserts further back in the call chain, or by adding logger.error output. Add a few.
I tried to add some logs because debug I can't build debug because debug works. So
error.
I only can. Yeah, I only can add some log to trace the code.
It will output error no matter what.
Oh, okay. Error.
Yeah, so you could change some of the log lines to error, which hopefully won't substantially change the timing, depending.
Okay.
You see what I mean?
I see. Yes.
You'd have to be strategic about it, and it would probably take a number of tries, as some of them will change the timing enough to prevent the bug from happening. But that may help to give you some insight into what's going on. If nothing else, you could try to isolate the caller.
Isolate the caller?
Yeah, I don't know what the caller is. That's the problem. So that is a helper used throughout LBA node internal. But because of the way CStar works, the backtrace doesn't contain the caller. It just contains the trampoline from the reactor. So we don't actually know what called it. We don't know where in LBA node it's being called from.
Sure. So I will add some messenger and log some error messenger. Okay, to trace the.
But so what I'm saying is I would go look at all of the callers with an LBA internal node and try getting one error log in each of them so that you can see hopefully what the last log line was, although even that will be a little bit misleading, but it may be of some value. Then you'd at least be able to isolate where it came from. When I try to debug this myself, what I'm going to do is I'm going to start by trying to change details of how the block implementation works until I get lucky and I'm able to reproduce it myself. I think that's what I'm going to have to do. What kind of hardware are you running it on, by the way?
Pardon?
What kind of hardware are you running it on?
PCIe SSD, I think.
Do you know if it's NVMe? So yeah, it's NVMe?
Yeah, NVMe.
I am too, unfortunately. I expect you're using faster hardware, though, so maybe that's the problem.
So I changed the different hardware tab that would works?
Well, no, that'll get rid of the bug, which isn't... We want to fix the bug. The goal isn't to avoid the bug. The goal is to
Yeah, I see.
I'm trying to work out what I need to do to emulate your environment. But if you're basically if you're running on faster hardware than I have, then I can't do anything with that because I don't have anything faster than the hardware I have.
Okay.
Although I could check the CPU lab. Actually, I think there are some with faster PCIe drives. Anyway, that's what I'll look into when I get around to it. I would move on to something else for the time being, though, if you don't want to spend time debugging it.
Okay. I will do something. Yeah, that's all.
Sam?
I just put up a large pull request refactoring a big chunk of the OMAP manager. Chunmei, if you could take a look, it's hang on, where'd I put it? This one.
Oh, by the way, he also replied me over the IM. He was on vacation actually. So no
He actually
progress
fixed it.
on his side. Yes, he
Fixed a
had
bug
fixed.
today. I'm sorry. I emailed him about it, but I figured he'd ignore it. Anyway, that's it for me.
Okay, thank you. Xuehan.
Last week I worked with Kofu and with an optimization for the client request sequencer, and I also reviewed some of his PRs. And right now I'm working on optimizing the parallelism of the Crimson OSD, specifically the parallelism of its client request pipeline. I have one question. I think the correctness of this parallelism optimization is rely on one point that the client requests are persisted to the underlying disk in the exact order of their arrival at the OSD. So I think the classic OSD accomplished this by first making sure that there's only one client request for each PG at any time point, and the Blue Store would make sure that the client requests are persisted to the underlying disk in the exact order they are submitted to the Blue Store.
That's correct. It's part of the interface. That's what the sequencer is for.
Okay, but after reading the code of Alien Store, I think if we, it looks to me that the Alien Store doesn't provide the same guarantee that it would persist the client request. Because when we submit a client request to the Alien Store cache it in a buffer, and there's a thread pool.
Right.
That thread pool will submit the client request to Blue Store, but the order the thread pool submits those.
Are you certain that it isn't being ordered by collection? Because that's the correct ordering criteria. Chunmei, can you speak to this?
I think it does not guarantee the order.
Okay, so a couple of things. What do you mean by the same order, quote, of arrival to the OSD, unquote?
I mean the order of the PG log entries.
Correct. So the point at which we decide what order the PG log entries is, that's the order they have to be persistent in the object store. That's right. Let's go look at Alien Store real quick. All Alien Store really has to do is ensure that the order of submission matches the order of submission to Blue Store. So hopefully it should just work. See here.
I think we need to take a look at the thread pool, how thread pool order the scheduled tasks.
I don't know if I'm correct about this, but I think it just pull the requests out of the buffer and submit to Blue Store.
It does not depend. guarantee the ordering, right?
Shenmei, can the thread pool have more than one submission thread?
Thread pool currently. What do you mean the thread?
In alien stored do transaction, you just blindly call TP arrow submit. This is not ordered. If you do this on a thread pool with 4 threads and you submit 4 operations in the same collection, there's no guarantee they'll be submitted in that order to the store.
Oh, that is
My
not
question to you
order.
is it ever the case that the thread pool has 2 threads or more?
So
Sorry, please.
I add a gate there to guarantee some order.
Okay, you're right. Joyhan, this is wrong. This won't work.
Okay. I want to make sure that C-store would guarantee the.
Yes, it does.
Okay. And so I just have to do some work within the alien store, right?
You may assume that operation. This is an interface property of the futurized store interface. Any implementation that fails to uphold it is buggy. So the bug is to be addressed in the implementation, not in your code. Does that make sense?
Okay. Yeah, it makes sense to me.
The specific guarantee is that any 2 transactions submitted on the same collection will be completed in that order.
Okay.
All bets are off if they're on different collections, of course, but that's different. That's how we enable any parallelism at all. As in every PG gets its own collection, so that allows us to get parallelism at a PG level, even if not within one. So concurrency within or pipeline within one, parallelism across them. So in the meantime, I don't think we got an answer to this. Are there ever 2 threads here, or is the thread pool always just 1?
We just increase the number of the threads in thread pool to like 6.
Okay, well, this needs to be 1 for now.
Yeah.
We'll get the wrong answer otherwise.
Otherwise, we need to have a sequencer to keep the order.
Which would be the correct answer, yes.
Yes, that defeats the purpose of increasing the number.
No, it doesn't. Why would it? That doesn't make sense.
Oh, sorry. I not use the gate. I use a mutex, the C-star mutex to guarantee the order for the TP summit.
Yeah, it is. I think that mutex is guaranteeing the order. The client requests are submitted to the alien store, not alien store to Blue Store, right?
Oh, I see. Yeah.
That's correct. Yeah. All that guarantees is that you submit to the thread pool in the same order that the transaction was called on. Of course, that was true anyway. What you needed to guarantee is that the things that come out of the TP submit call are the same order that they came in with, based on collection ref. Something analogous to a pipeline would be the way you do that. Shohan, do you think you'd be up to adjusting this? I think it's not enormously complicated.
Okay. I'm trying to do that. I just don't know if it is correct to implement those correction within the scale of alien store.
I think so. Yeah. So one really simple way to do this would be to hash the collection onto the set of threads, so that any 2 transactions in the same collection end up on the same thread. That should guarantee ordering. You may have to look at the thread pool implementation within C-star to make sure, but that's how I would do it.
It's quite like the sequencer, the way how we implement the sequencer, which groups the operations by PG, but in this case we group the operation by collections.
Yeah.
Right. If you don't do that, I suppose what you could do is you could restructure this so the thread pool is an independently running collection of callbacks on each thread that are pulling from a set of queues. There are a lot of ways to do it.
Like sharding the thread pool into different collections, right?
But I think the thing you should look for most is that C-star should have its own way of doing this. It should have its own utility for this. Which would be the simplest way to do it.
Sam, sorry, I don't follow you. What do you mean by the CSTAR should have its own facility to
This is
do
an
what?
incredibly common pattern. You need to submit items to a collection of threads, and there's a non-complete ordering within that set. This is very, 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 very common in distributed programming. So I bet CSTAR already has a library for this. The same way it already has a library for a thread pool in the first place.
I still don't
It may
get
not
it.
have
But the thread pool is implemented in alien threads. So that's what.
That's not the point. The point is they should already have a data structure to make this easy. It'll be layered on top of other things.
Okay.
This thing where you're
Start
so like
service.
you have a set of things you need to submit to a set of parallel cores, right?
Right.
There is an ordering that is not total. If there were total ordering, then having multiple threads would be pointless. You could only ever utilize one. But if you have a sub-ordering, some kind of lattice sub-ordering within that set, and you can say you can partition all of the incoming things among a set of tokens and say any two things that map to the same token, they have an ordering restriction. Then all the backend implementation has to do is make sure that any two things with the same token go to the same queue and then go to the same thread. Easy, right?
We need to have a dispatcher which could dispatch the request with different tokens and dispatch to the right.
No, I'm saying this probably already exists within CSTAR. If it doesn't, I would have already written one of these in CSTAR.
Okay.
It's just a really common thing applications will want.
Okay.
Rayhan, it doesn't mean they have one. It just means that it's worth looking. That's all.
Okay, I see. Okay, that's all for me. No more questions.
Okay. Anything else?
Nope. Hang on. Well, I wanted to talk a little bit more. So you can take a look at the way. Is the implementation of file store still there? Because what file store did is it, for each collection, had its own internal queue. And when you queued something, you didn't queue the op, you queued the collection. And then when you take the collection off the queue, you lock the collection mutex and then pull the next thing off of the collection queue. That ensures that even if two threads do happen to grab the same collection at the same time, only one of them will pull the next op off. So that would be a crude but simple way of ensuring ordering. I wouldn't overthink it. I think. This probably won't turn out to be a bottleneck, but if it is, well, we'll put some more effort into it after we have actual benchmark numbers. Better to be correct first and then fast later.
I recall there's also a sequencer in file store, right?
Yeah, like I said, they all have this property because the OSD relies on it heavily. What I mean is the specific implementation in file store is what I'm describing.
Okay.
Where each op sequencer or collection these days has a queue in it, and you don't. So when you queue things for the thread pool, you don't queue the thing you're queuing. You first put it into the queue for the sequencer, and then you queue the sequencer. So if two threads happen to pull the same sequencer off, only one of them will win the race.
Yeah,
because they'll lock the mutex in the sequencer, they'll get the next operation, which is well defined, submit it, release the lock, and then move on with their lives. In this way, we guarantee that as long as we NQ and DQ the sequencer the same number of times, we'll always go through the full queue. And we'll do it in order. So that would be a very simple way of doing it, which I think would be fine.
Yeah, I got that.
But I got another question. If we want to parallelize the processing of the request, parallelize the processing procedure, grabbing the request from a PG, we cannot use multiple threads for grabbing the request from the same held by the same collection. Because
that's literally true. That's the actual constraint. That's correct.
Yeah, because in our this rare use case where we have a alienized backend.
It doesn't matter. This is fundamentally true. It's a fundamental property of parallel processing and ordering.
I mean, we might do yet another sequencer on the other end, on the alienized.
Yes, and ideally we would reuse it, but who cares?
Yeah, because okay, I got it. I got a point. Because we already have a sequencer on the alienized world, so it's safe.
Yeah, I mean, I see what you mean. Yes, as long as do transaction queues for the thread pool in the same order in which the OSD called do transaction, the thread pool calls
Submit to
Blue Store submit transaction in the same order in which things were queued for the thread pool, and submit transaction maintains ordering itself because Blue Store is correctly coded, then we're fine. All we're talking about here is basic ways of doing maintaining ordering of items queued for a work queue. It's a pretty basic problem. And you're correct. If all of the things were queued on the same PG, there is no way for us to make use of 2 cores anywhere. In this process, because if we're processing writes, they must be processed in order. A more clever, optimistic execution system might be able to do speculative work, and then no, really,
CPU core.
Actually, C star will do this to a limited degree. In C star, while you must submit them in order, it's possible for something earlier in the pipeline to begin doing all of the reads it needs to do. But if it turns out that it conflicts with something later in the pipeline, it'll fail and retry. But if it succeeds and it turns out that they didn't actually touch anything in common, and there's no way for a user to have observed a different outcome, then it will end up having done a lot of their work concurrently. Not on 2 threads, because that's not how C store is going to work, but concurrently, overlapping.
Sure. I don't really think C star scheduler had an understanding of the global
This isn't a scheduling.
picture.
Like I said,
side effects.
It has no clue. That this isn't about C star. This is about C store.
Okay.
Actually, just ignore everything I just said. In the normal course of events, if you have to process 10 things in order, there is no way to do that on 2 cores. They must be done on a single core in order. You can bounce them between cores, but that's not really utilization, right? So the way we get parallelism here isn't by processing the same PG across multiple cores. It's by having 100 PGs.
Yeah, agreed. Yes, the way how we parallel this processing procedure is to take advantage that we have like hundreds of PG instead of parallel the operations targeting to the same
But
PG.
the other half is also really what I'm trying to tell you. It's fundamentally impossible. It's a logical impossibility to do otherwise. As long as we require operations to be ordered between where the PG sets the PG log entries and where they're committed to disk, we are effort we apply to this. That choice alone limits anything we can do there. Which is why we choose to have multiple PGs and to exploit parallelism that way. They're both true.
Because we have a single point of a sequential, right?
It's Amdahl's law. You can't achieve more parallelism than the ratio of the longest sequential portion of a computation execution to the overall computation required. So if half of the total computation required is fundamentally sequential, then the best speed up you can get is a factor of 2. In our case, 100% of it is sequential. So on a single PG, the best you can get is a speed up of 1. You can't use 2 cores. It's a basic observation in computer science.
Okay.
If we wanted to get around that, we would have to do other things. But the way we choose to do that at a systems level is by breaking the ordering requirement between PGs. Hence, why literally the entire rest of the entire system is architected around having a lot of PGs.
I'm sorry, I don't get. Does the ordering between PG make sense?
There is no ordering between PGs, which is why we're allowed to operate in parallel there. Do you see what I mean?
No,
because
I do think we don't need this ordering between PG. We need
There,
we
no,
do
no, no.
need.
I'm telling you that there is no ordering between PGs. That's correct.
Okay.
They are
Okay.
unordered. And for that reason, for that literal exact reason, we are allowed to use multiple cores. Does that make sense? Because we have multiple actual parallel threads of execution that don't interact at all.
Yeah, that makes sense to me.
Cool.
Anything else? Nope. Nope. Okay. Talk to you later. And have a good one. Thank you.
See you.
Yeah.